So let's finish up with our discussion of thermophysical properties in the steam tables. So we said that we are going to find data. We've got some data in our textbook or in other textbooks. We can go to Perry's and find some. We're going to find two properties that we're going to be given, or I'm going to have to measure when I go out in the industry. So two things need to be known, and then that defines everything else. So I can go to a table and look those up. I begin by identifying the phase, and then if it turns out to be a liquid-vapor combination, I'm going to determine the quality, which is a ratio of how much is in each phase. So specifically, the way quality is defined is the mass fraction that's vapor. Okay? You will sometimes see places that talk about the liquid fraction, but quality means the mass fraction that's vapor. If you use a G to denote the gas or the vapor phase and F to denote the liquid phase, then you can define quality as in this slide. Now, I'm not going to go through the full details of this derivation. You should have seen it in a previous course. But essentially, if I want the mass fraction that's vapor, I'm going to take the mass of the vapor divided by the total mass, and I can relate that to volume. Going through and doing some fairly simple algebra, I end up with that the volume is the volume of a saturated liquid plus the quality times the volume change, Vg minus Vf, or sometimes we call it Vfg. I could also solve for quality is the volume minus the volume that's saturated liquid divided by the volume change from being liquid to gas. Now I wanted to spend a moment talking about how we identify phases. If temperature is one of the pieces given, then use this little chart. If my second piece of information is pressure, then I'm going to look for the saturation pressure on the saturated data table. If the pressure is the same as that, then I know it's saturated, but I can't tell you if it's liquid, vapor, or something in between. If the pressure is higher than this, so I've taken this and I've applied more pressure, the molecules are closer together, that's a compressed liquid. If the pressure is less, then I've let the molecules be free to expand, and that's going to be a superheated vapor. Now, if I have temperature and volume as the second piece of information given, then I'm going to again go to the saturated table and look up the saturated volume for liquid and for vapor, saturated liquid, saturated vapor. Either the number is between, or it's smaller, or it's larger. Now, if it's between, it means I've got a combination of liquid and vapor. If it's a larger volume, then the molecules are free to spread apart, and that's going to be a superheated vapor. If the volume is smaller, then that's going to be a compressed liquid. Okay? I can also do this. The rules work in the same way for U, H, and S. If you just remember that mathematically they work like V, it helps usually with being able to use those. Volume, I feel like you usually have a pretty good grasp of, oh, more space, that's more like a gas. Now, if the pressure is given, and T is the other piece, and you look up the pressure, then again, you start at the saturated table, you look up the saturation temperature. If it's the same, it's saturated. If it's higher, it's a superheated gas, right? More energy makes the molecules move apart. If it's cooler, it's a compressed liquid. It's condensed. If you have volume given with pressure, again, I'm going to look for the saturated liquid and vapor. If it's in between, it's a saturated mixture. I can determine the quality. If it's a larger volume, superheated gas, a smaller volume, then it's a compressed liquid. So let's look at some examples. So this first one here, I have propane at 8 degrees C with a specific volume of 1.931 times 10 to the minus 3. Okay? Now, again, I gave propane tables in the course website. So if you go to that, you'll be able to follow along with this. So you go to the saturated table. and you find the given temperature in this case. So 8 degrees C, it's at the bottom of the excerpt that I've shown right here. Okay, so here's the data for that. Now, what I have is VF times 10 to the third is 1.931, VG is 0.07666. Now, the key thing here is, notice the way that that's written. This says that VF times 10 to the third equals 1.931. That means VF is 1.931 times 10 to the minus third. The units are meters cubed per kilogram right up here. And then VG is just simply this number because they don't have anything fancy in the column heading. All right, so this is what I'm looking for. So in this particular case, I have a saturated liquid, and the enthalpy is going to be the enthalpy for a saturated liquid. In this case, 115.5 kilojoules per kilogram. So let's look at another one. Different value, 20 degrees C, and a different specific volume. So again, start at the saturated table. I look at 20 degrees C, and the saturated volume is 0.0324, which is in between these two. Remember, this is times 10 to the negative 3. And so since it's between, I want to determine the quality. So, quality, using the definition calculated here, is 0.08622. So 8.6% of this mixture is vapor, so 91.5% is liquid. To finish this up, you use that quality to determine H, using the same formula with H substituted in. This third example, 10 degrees C and yet another specific volume. Well, in this particular case, what happens is you go to the saturated table and 10 degrees isn't on the table. Okay? So I have a choice. I may have to figure out what it should be at 10 by estimating, or I can just take a moment and spend a moment with some logic. And the specific volume is 0.1674. Well, that's larger than the VG for either of those temperatures. So I'm going to assume that that means it's superheated. So what I want to do is go through the superheated tables for propane at 10 degrees C and scan through there until I find a number that's 0.1674 or very nearby. So what I found is that at 2 bar, the pressure is 2 bar, then at 10 degrees, V is 0.1674, and so therefore H is 494 kilojoules per kilogram. Now all of these examples, the numbers showed up on the table, okay? When the number isn't explicitly in the table, you're going to have to interpolate. So you should have learned linear interpolation. It's a very traditional tool. What we're going to do is we assume that a straight line between the 2 points is going to give us a really good approximation. Okay? So using this definition of slope between 2 points, we end up with this equation shown here. And I just apply that to calculate the other numbers. Okay? Now, in Excel, I can do this using the forecast function, but you also probably have something in your calculator. Now, when we get to looking at the homework and the solution, I will use this forecast function there, so you'll get a chance to try it. But just look for it on your own. If you are familiar with Excel at all, it's pretty easy. Once you type a function in and put the parenthesis, it gives you all sorts of help. So let's very quickly go through these. Now, these are going to require a lot more side calculations, so you'll want to pause the video going through these. I'm going to talk through them very quickly. You'll want to pause and make sure that you understand exactly how these numbers were obtained. So first, find the temperature of saturated vapor propane. So we know that it's saturated vapor propane when the internal energy is 330 kilojoules per kilogram. Okay, so we're going to just find UG, scan through the list and find the numbers that are closest to 330. And it turns out negative 90 and negative 80 degrees C are the temperatures closest. The values of U are shown there, and then we apply the definition for interpolation, and it turns out that it's negative 89.3 degrees C. Again, pause the video and take a moment to check it out. This next one, I have a pressure of 12 bar and an entropy of 2.04, and we want to find the temperature there. And so if you go through and do this, just check it out, you're going to see that between 80 and 90 for the superheated 12 bar, you end up with these values of S. And again, you get to interpolate. And then find the pressure of propane at 50 degrees C and enthalpy of 540. And again, at 10 bar you find this, at 12 bar you find this, very close to the two numbers, and we end up with 11.5 bar as our answer. So at this point you should be prepared to take the quiz, okay, and do homework 1, upload that, I'll get it graded and get back to you. In the meantime, you can go ahead and start working on Module 2.